Hello everyone, I am S.V. Subanu pursuing BA Computer Science in Sethu Institute of Technology. In software engineering practices, my seminar topic is interface segregation principle. Before going deep into the topic, let us have a brief note on solid principle. A solid is a popular set of design principles that are used in object-oriented software development. The solid principle was introduced by the famous computer scientist Robert J. Martin in 2000, but the solid acronyms was introduced later by Michael. In solid acronyms, the S stands for the single responsibility principle, O for open closed principle, L for Lisco substitution principle, and I stands for interface segregation principle, and D stands for dependency inversion principle. The main aim and the motive of the solid principle is to create understandable, readable, and testable code that many developers can collaboratively work on. Interface segregation principle. Interface is defined as an abstract type used to specify the behavior of the class. It will act as the blueprint of the class. The word segregation means separation. ISP states that no code should not be forced to depend on methods it does not use. The ISP splits the interface that are very large into small and more specifically ones, declaring the method in an interface that the client does not need pollutes the interface and leads to the bulky or a fat interface. The client should not be forced to depend upon the interfaces that they do not use. A definition given by Robert Martin for interface segregation principle. Advantages of ISPs is to increase the readability and maintainability of our code by reducing our class implementation only to the required actions without any additional or unnecessary code. This principle is very powerful concept to master when developing a Java application. For better understanding, here is an example. Consider the requirements of an application that builds different types of transportation vehicle. Each vehicle will have a price and a color. The vehicles such as car can start, stop, move and moving, while some vehicles such as aeroplane can both move and fly. A class that represents an aeroplane can implement the vehicle interface and promotes the implementation to all the interface methods. But imagine a class that represents a car. This is how a car class will look. As you can see in the code, the car needs to provide an implementation flight method, even though it does not require them. This is in violation of ISP. We can address the problem of vehicle interface by giving a solution like segregating the vehicle interface into multiple role interface, each for a specific behavior. Vehicle interface can be broken down into toy, movable, and flyable. This interface with set price and set color methods, as all the vehicles will have a price and color. Then movable and flyable interface to represent the moving and the flying behavior in vehicle. Now the class implements these interfaces they are interested in, and this helps to remove the unnecessary code. The implementation of the car, class, and the aeroplane is presented here. Conclusion. The ISP is a straightforward principle that is also easy to violate it by adding methods to the existing interface that the client does not need. Remember that an overly aggressive implementation of any principle can lead to other issues in the code base. I hereby concluded my presentation. Thank you.